Okay, y'all, so we're going to be talking about Pythagorean theorem today. This really should have been last time, but I went ahead and taught y'all Heartbeat and Benny. So with Pythagorean theorem, y'all have done it multiple times before, but remember it has to be a right triangle for you to do that. So the parts of the right triangle, and we talked about this last time a little bit, we have the two legs, okay, and then your hypotenuse is always located across from the right angle. So that's how you can find it. So when some of these triangles are flipped around, rotated, flipped, whatever, you can identify that hypotenuse because it's across from the right angle, and then the other two pieces are going to be called our legs. And then for the Pythagorean theorem, it's a squared plus b squared equals c squared. It is on the formula chart, but you should be able to have that memorized. Okay, so let's look at this first example. So we have 3 and 7, those are our legs, and then the x is our hypotenuse. So we're going to have 3 squared plus 7 squared equals x squared. So that's 9 plus 49 equals x squared. That's 58 equals x squared. And then we did a lot of practice on this last class, so we're going to square root this. And then remember, you can go into your calculator, you go to your y equals, type in 58 divided by x, and then you want to pull up your table. Okay, and in that table, we're looking for the perfect squares. And there's actually not any perfect squares in 58. And so we will just be leaving that answer as the square root of 58. I'm just double checking that real quick, but I don't think there was. Yeah, there's not. Okay, so x is just the square root of 58. Okay, number 2, this one's a little bit more complicated, but it's definitely a question that you would see. So it's, we've got the legs, so we've got 4 squared plus, be very careful here, this is x minus 2 squared equals x squared. Whenever you square that binomial, so I'm going to go ahead and do 4 squared is 16. You need to write this out as x minus 2 times x minus 2, because what's going to happen if you don't is you're going to end up missing probably 2 of the terms that you're going to need. So I need to FOIL this. So I'm going to have x times x is x squared. X times negative 2 is minus 2x. The inside is minus 2x, and the negative 2 times negative 2 is plus 4. Okay, so I've still got the plus 16 at the front. And then now I am going to just combine my like terms. So I've got the 16 and the 4, so that's 20. I've got that only x squared, so I have plus x squared. I have negative 2x and negative 2x, so that's minus 4x. And then I have the x squared on the other side. And so at first glance, you think that you're going to have to factor this, but we're actually not going to have to, because when we have that x squared on both sides, they're going to cancel each other out. Okay, but notice we don't have anything on that right side anymore, so I'm going to add the 4x over. So I have 20 equals 4x, and then divide by 4, so x is 5. Okay, so definitely a little bit longer one, but it's definitely something that I could give you. Okay, this next one, you don't see any right triangles here, but remember last time we talked about altitudes? If I were to draw in that line right there, okay, I now have a rectangle and a triangle, and I've made a right triangle. So I have that 5, so directly across from that would be 5, which would lead this piece to be 6. And then 8, directly across from that would be 8. This is actually, we're going to talk about triples here in a little bit. This is a triple, so I can look at x, and I know what it is right now, but you don't. So we would have to do Pythagorean theorem. So we're going to do 6 squared plus 8 squared equals x squared. That's 36 plus 64, which is 100. And then you take the square root of that, and so x would be 10. All right, this next example, I'm going to show y'all next week how to get this answer really quickly, because these are special triangles, but for right now, all you know to do is Pythagorean theorem. So it's showing you this is a square, so every side is x. So I'm going to have x squared plus x squared equals, be very careful here, we need to square that entire thing, so you need to be putting that 5 root 2 in parentheses. Okay, that's a little thing that will completely throw off the problem. So I have 1x squared plus 1x squared, so that's 2x squared equals, now this is like doing 5 root 2 times 5 root 2. Okay, when we reviewed stuff like this last time, how we do the outside times the outside. So that's 25. And then remember, a square root times itself is just the number underneath. So square root of 2 times square root of 2 is 2. Okay, so what I have right now is 2x squared equals 50. If you type that in the calculator, that 5 root 2 times 5 root 2, or you type it how it was given to you at the beginning with the parentheses, it'll tell you it's 50. So you can check that in the calculator. All right, so now I'm going to divide by 2. So I have x squared equals 25. And now I can take the square root, so x is 5. Okay, so again, just something small in that problem. It's not very hard, but just one little mistake on that, and it's going to mess you up. All right, so these are the triples that I had mentioned. This looks overwhelming at first, but there's nothing here that you absolutely have to know, because if you just know how to do Pythagorean theorem, you don't have to know the triples, and you definitely don't want to mess them up. And so I'll tell you the ones that I know. Like I know the 3, 4, 5s. So this is basically saying if you have one leg that's 3 and another one that's 4, then I know the hypotenuse will be 5. Or if I have one leg that's 6, another leg that's 8, I know the hypotenuse is going to be 10. Everything under that 3, 4, 5 column, those are all that same triple. It's just 3, 4, 5 times 2, 3, 4, 5 times 3, 3, 4, 5 times 10, 3, 4, 5 times x. Okay, so those all are falling under that category. I also know the 5, 12, 13. Okay, but if you don't know it, you don't know it. It's not that big of a deal. You just use the Pythagorean theorem. Okay, there will be some of these on your homework today, and just keep this list in front of you and you can answer those questions really quick. Okay, so that example down there, it says the legs of a right triangle are 3 and 4. What's the hypotenuse? So 3, 4, 5. The hypotenuse would be 5. Okay, that's a real easy one that I really think we should all know that one. It would be silly not to know that one. Number 2, it says the leg and hypotenuse of a right triangle are 24 and 26. What is the length of the other leg? So if you look at this chart here, you can see that one that has 24 and 26. That means the other leg would be 10. So you can see that from that chart. So again, not that big of a deal if you know these, but you will hear me talk about triples. Okay, this is the part that is not hard, but it will get missed. So let me kind of talk through it. So we know that if we have a right triangle, that means a squared plus b squared equals c squared. Okay, well now what we're going to be looking at is, what if I give you a set of numbers and I ask you what kind of a triangle is it? Okay, it might be a right triangle, it might be acute, it might be obtuse. Okay, now before we can decide what kind of a triangle it is, we have to make sure it even is a triangle. So if you think back to last semester, to even be able to qualify as a triangle, the 2 smaller sides have to add up to be bigger than the third. Okay, so if I have 3 sides, then the 2 smaller have to be greater than the third side. Okay, that's just to create a triangle. We may not even be able to make one, but if it passed that test, then what we're going to do is we're going to plug it into the Pythagorean theorem. This is the part that gets missed. You plug it into the Pythagorean theorem, okay, and then look at these things in like purple, pink, and green. It says a right triangle can be formed. So if you plug it in and a squared plus b squared equals c squared, then it's a right triangle. If you plug it in and a squared plus b squared is greater than c squared, then it's going to be acute. Now you have to be careful with that because you think that greater would mean obtuse, and it doesn't. It means acute. Okay, so you kind of have to think backwards there. That's just kind of my trick that I do. I just say, oh, it's going to be backwards of what I think it's going to be. If it's greater, it's actually acute. And then if you look at the next one, a squared plus b squared is less than c squared, then that's going to be our obtuse triangle. So again, just kind of thinking backwards there. If it's less, it's actually obtuse. Okay, so we're going to do these 4 down here. We first have to decide if it can even make a triangle. So on the first one, is 5 plus 4 greater than 12? I have to answer that question first. Okay, so is 5 plus 4 greater than 12? No, it's not even a triangle. So we don't need to check what kind of a triangle it is because it's not a triangle. Okay, so we can't classify it. Okay, B says 6, 7, and 8. So is 6 plus 7 greater than 8? Yes, it is. Okay, so yes, it is a triangle. Now we're going to plug it into the Pythagorean theorem and check to see what kind it is. So I'm going to have 6 squared plus 7 squared. I'm going to leave a space because I don't know what sign's going to go there yet. And then I have 8 squared. So if I do 6 squared plus 7 squared, it's 85. And then 8 squared is 64. So 85 is greater than 64, which means this is going to be acute. But again, the part that gets forgotten is that you have to plug it into Pythagorean theorem to be able to decide. Okay, which makes me a little worried that y'all are going to do the class kick and you're going to just type it in until it turns green and you're never going to actually know how to do it. So make sure that you're showing your work on that you're plugging it in, just like you saw the work that I just wrote down. All right, C says we've got 1, 3, and square root of 10. Now, I don't know what square root of 10 is off the top of my head, so I'm going to type that in the calculator, and it's about 3.2. Okay, just to get an idea, because I don't even know what number would be the biggest here, okay? But now I can see that that is the biggest. So is 1 plus 3 greater than 3.2? Yes. So it is a triangle. Now I'm going to plug it into Pythagorean theorem. So I'm going to say 1 squared plus 3 squared. Again, I don't know my sign yet. And then I have square root of 10 squared. Okay, now I don't have to have the parentheses on that when I square it, but if there was something in front of the 10, I would need them. So I'm just going to always, if I'm going to square it, I need to put parentheses around it. Okay, so that's going to be 1 plus 9, which is 10. And then the square root of 10 squared, that's square root of 10 times square root of 10 is 10. So 10 equals 10, which means this is a right triangle. Okay, the next one, this looks difficult. It's actually not going to be. But if you add the two smaller ones together, they are more than 27. So it is going to create a triangle. Okay, and now I'm just going to check to see what kind. So I'm going to have square root of 9 squared plus square root of 16 squared. And then I don't know what it's going to be, but then I'm going to have square root of 27 squared. Square root of 9 squared, that's just like root 9 times root 9, which is 9. Root 16 squared would be 16. And then root 27 squared would be 27. So that's 25 is less than 27, which means this is obtuse. So you can see one of each kind there. We had an acute, a right, and an obtuse, and then one that wasn't a triangle at all. All right, we are going to do, there's quite a few graphing ones here. I'm going to do just one of these. I don't think we need them all, and then you'll have a couple on your homework. So it says, find the length of the hypotenuse formed by the given equations. We've actually already done these this year. We just didn't call it find the length of the hypotenuse. We called it find the distance. Okay, so that's what we're going to be getting is the distance. So I do need to graph these 3 lines. So to graph this first line, I need to subtract the 3x. So I have y equals negative 3x plus 4. So I'm going to go ahead and graph that. So I'm going to start at 4 on the y-axis. And then my slope is -3. So I'm going to go down 3 over 1. Down 3 over 1. I'm just going to keep going because I don't know how far to go yet. Okay, so I have this line. Okay, that second line is y equals. So think about HOI right here. HOI tells us this is going to be a horizontal line. So I'm at -2. And then I have this horizontal line. And then that third line, x equals 1, think about VUX right here. That tells me this is going to be a vertical line. So I'm going to start at -1, and then I have this vertical line. Okay, and what you'll see is this triangle that has been formed. Whoops. This triangle that has been formed by these 3 lines. And we are looking for the length of the hypotenuse. Okay, so I'm going to count the 2 sides of this triangle. So if you look at the bottom, it's 1, 2, 3. And then be careful, if you haven't drawn your lines good, you could be 1 off on the left side of that triangle. So just make sure you go all the way up to that point. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9 over here on this side. So I'm going to have 9 squared plus 3 squared equals c squared. That's 81 plus 9, which is 90. Okay, and then we're right back to what we practiced a lot of last class, which is square roots. That 90 is going to break into 9 times 10. Remember, you can go to your y equals and you can pull up the table and look if you need to. So the square root of 9 is 3. So I'm going to bring that out, and then that leaves me with the square root of 10. So I have 3 square root of 10. Okay, so make sure you do your class kick after all this. Make sure you're showing your work on that so that I know that you actually did it.